In this video, we're going to learn to translate contextual problems into inequalities. So let's read the first problem. The fire code states that there can be up to 50 people in a certain classroom. So let's read the different questions. So first we're asked to define the variable. So what's the variable here? What's the unknown or the value that could change? And that would be the number of people in the classroom. So I'm going to let n equal, I'm going to call it n for number of people, the number of people in the classroom, and specifically we're interested in here the number of people in a classroom that will meet the fire code regulations. So we want to include that. So there could be any number of people in the classroom up to some point where no one else would fit, but we want specifically the number of people in the classroom, we'll say allowed by the fire code. So always try to be as specific as possible. Now we're asked to write a symbolic inequality for this statement. Okay? So we're comparing here the number of people in the classroom allowed by the fire code to a boundary value of 50. So I'm going to put n and 50. Okay? And I don't know which inequality symbol I'm going to put in here. Okay? So that's what we're going to figure out next. So we want to see the relationship between n and 50. So the key words here are there can be up to 50 people in a certain classroom. So is that going to mean, first we're going to determine, is that less than, is greater than? Which one of these does it represent? Okay. So sometimes the language can be tricky. There's lots of different ways to say these things in the English language. When we worked with the symbolic language math form, we just say is less than or is greater than, but here you have to do some interpretation. So one way to think of this, I think thinking about money and how much money you make always helps because we can all relate to that. If I said you made up to $100 at work today, well, that would mean you made any value less than $100, and the up to means that $100 is the maximum, so you could have also made exactly $100. Okay? So up to is going to mean less than or equal to. Okay? So the number of people in the classroom allowed by the fire code is less than or equal to 50. Okay? So that's how we translate this inequality. Now, inequalities in general are true frequently for an infinite amount of numbers and false for an infinite amount of numbers. So they're conditional statements. So we're going to list two values of the variable that make the inequality true and two values that make the inequality false. So two values for n that are less than or equal to 50. So I'm going to say, well, 20. So if there's 20 people in the classroom, that would meet the fire requirement code. And also I'm going to use 50 because that's right on the boundary. And notice 50 is okay. If we replaced n with 50, 50 is less than or equal to 50. That is a true statement. Okay. Now, two values that make the inequality false. Okay, so that would be values that violate the fire code. So notice if you had 51 people in the room, that officially violates the fire code. And then we could also have 100 people would definitely violate the fire code. Okay? So a few things to note as we're just learning to create these. Officially, this says a number less than or equal to 50. Now we know some values that are impossible for n. So for example, you can't have a negative number of people in the classroom. Okay? So the smallest n can be is 0. Okay? So when we work in contextual problems with inequalities later, we're going to be more specific about the values that we allow to n to represent. Another fact about this situation, notice n couldn't be 2.7. Okay? because you can't have 2.7 people. So this problem actually has a finite, meaning you can actually list all of the numbers of answers. It would be 0, 1, 2, 3, 4, 5, all the whole numbers up to 50. Okay, so let's look at the next one. The number of minutes it takes to drive to Phoenix is more than 20 minutes. So notice I stopped at is more than. I'm going to highlight that a different color. So when you see is or was, that's usually indicating the type of connective you're going to use. Okay. So first, let's define our variable. So the amount that varies or that we don't know is the number of minutes it takes to drive to Phoenix. So let's call that, I'm going to call it M for minutes. So M equals the number of minutes it takes to drive to Phoenix. Again, I'm trying to be very specific. You don't want to just put M equals minutes, okay? And even if you just put M equals number of minutes, is it the number of minutes to bake a cake, to watch a TV show? You really want to include all of them, and I just ended Phoenix with a Z. Sorry. Okay, so you really want to be specific so you know what your variable defines. Now we want to write a symbolic inequality for this statement. Okay? So let's look at our connective. We're relating the number of minutes, M, and here's our boundary value, 20. So there's some sort of relationship between M and 20, some sort of connective. Okay? So here we have is more than. Okay? And that doesn't directly say is less than or is greater than, but let's think about what is more than means. Okay? So let's go back to how much money you make. Okay, say you work today and the amount you made is more than $100. Okay, so your friend asks, maybe you wait tables, how much money did you make? I made more than $100. Well, that would mean that you made greater than $100. Okay, so this is going to be a greater than symbol. Okay, and also it excludes the possibility that you made exactly $100 because more than means more than, not equal to. Okay, so is more than is actually synonymous with is greater than. So we're going to put the symbol this way. So M is greater than 20. The number of minutes it takes to drive to Phoenix is greater than 20 minutes. Now let's list two values of the variable that make the inequality true. Okay. So it could take you, let's say, 25 minutes to drive to Phoenix, and 25 is greater than 20. Or it could take you 75 minutes. There's fun Phoenix traffic. And 75 minutes is greater than 20. Okay. List two values of the variable that make the inequality false. Okay. Well, if it takes you 2 minutes, that must be false because 2 minutes is not greater than 20 minutes. Okay. And even 18 minutes would not make this inequality true because 18 minutes is not greater than 20 minutes. Okay. And again, notice there are values that don't make sense. Again, the number of minutes you travel cannot be 0 or negative unless you have a TARDIS, Doctor Who reference. Hopefully it would never take you 20 million minutes to drive to Phoenix. This allows for that situation. I could put 20 million here, but that wouldn't make sense. Okay, so again, whenever we're working in context, we're defining abstract mathematical statements, but we also have to remember the context itself to see which ones make sense. Okay, we'll continue the next ones in the next video.